Okay, this video is going to be looking at question 4, part 2 of the June 2014 FP1 Edexcel paper. We've already looked at part 1, okay, and part C is basically giving us a matrix, C, where K is just a real number, and it's asking us to find C to the minus 1. This is known as C inverse, and it's giving your answer in terms of K. So basically, all that last bit saying, give your answer in terms of K. All that's saying is your final answer will have a K in it. Don't worry about that. Okay, and there's 3 marks available for that question. Okay, so I've written C out here. Let's just talk a little bit about what an inverse is. Okay, an inverse in sort of real numbers, so look, if you have the number 5, then the inverse of that be 1 over 5. Remember, 1 over 5 is just 5 to the minus 1, which is where this notation comes for inverse. Okay, and the idea is that if you multiply these two things together, you're just going to get 1. Okay, so the idea with matrix multiplication is if you have C, this matrix here, C, and you multiply it by its inverse, then you'll get the equivalent of 1 in the matrix world, which is the identity matrix. Remember, the identity matrix is where the leading diagonals are 1 and all the other elements are 0. So this corresponds to 1. Of course, you can't just write 1 in a matrix because that's not a matrix. Okay, you've got to correspond to the size or the dimension of the matrix. And actually, if you think about it, you know, a number, 5 is just a matrix. It's just a 1 by 1 matrix. Okay, and if you multiply that by its inverse, then you will get the identity matrix, which is 1. Okay, so actually, real numbers are actually matrices in themselves, but we don't normally call them matrices. Okay, so that's just basically the idea of what an inverse is and such like. So, what is the process? Let's say we just have a general matrix, D, okay, with elements A, B, C, and D. Okay, and it's a 2 by 2 matrix, by the way. This is the process of finding the inverse of a 2 by 2 matrix. You can also find the inverse of a 3 by 3 matrix. A little bit more work, but you can do it. Same with finding the inverse of a 4 by 4 and 5 by 5 and so on and so on and so on. But it obviously gets much more difficult as you go down the line. Okay. Oh, and by the way, there's some numbers which there's some things which you can't find the inverse for, and we call that singular matrix. Say, for example, if 0 in real numbers, if you want to draw a parallel with that, 0, if you multiply that by 1 over 0, 1 over 0 is infinity. Okay, so that is not equal to 1. Okay, so we say that, that is non-invertible. That's just a sort of little sideline. So let's get back to this. What's the inverse of it? Well, the inverse is given by 1 over the determinant of this matrix. We swap the leading diagonals and we negate the other diagonal. Okay, so I've written these steps down here. Find the determinant of this. Swap the elements of the leading diagonal. So you can see here that we had, whereas in D we had A and D. Here we've got D and A. Okay, and then we negate the B and the C. These two things here, and we multiply by 1 over the determinant of that. Okay, so I've just written that down there. So with the case of C, we've got, let's write it down here again, 2k minus 2, 3, and k. Okay, so first things first, we want to find the determinant of this matrix. So what is the determinant of C? Well, if you remember, the determinant of the C is it's basically just a cross. Okay, that's how I think of it. It's a bit like multiplication. Okay, so you multiply this matrix, the 2k, by the k. And then you take that away. Remember, it's take away this by this. Okay, so it's 3 multiplied by minus 2. So take away 3 times by minus 2. Okay, do a little bit of simplification. You've got 2k times k, that's 2k squared. Take away 3 times negative 2, that's minus 6, but we're taking that away, so it's take away negative 6, that's the same as adding 6. And that is the determinant. Okay, we can't do anything else with that. We could have, I suppose, if you wanted to, take a 2 out, but there's really no need. Okay, that is the determinant. Right, next process to find C inverse. So the C inverse is going to be 1 over this thing, that's the determinant. It's 2k squared plus 6. Then we're going to have to fiddle around with this matrix here. Sorry, I'll get rid of those 2 little crosses there. So we're going to swap the leading diagonals. So the 2k and the k are going to swap. So k and 2k. Okay, and then we're going to negate this diagonal here. So whereas before we had 3, now we're going to have minus 3. And whereas before we had minus 2, now we're going to have 2. And that is C inverse. So that's all there is to it. Okay, now where are the marks for that? Well, we're going to get 1 mark for attempting to compute for the determinant. Okay, even if you don't get it right, as long as you've shown that you've done roughly the right thing, as long as it's not too out there, you will probably get 1 mark for it. Okay. The other 2 marks, you get 1 mark obviously for the answer. Okay. The other mark is if you get the determinant wrong in the first bit, but if you show that it's 1 over the determinant of that thing, okay, multiplied by this matrix. So you do the right thing to the matrix, but because you got the wrong determinant in the first thing, okay, then you will still get a mark. Okay, so they're being really generous. They're basically saying, even if you don't get the right determinant, you can still get the full 3 marks.